So let me start sharing my screen. So today is lesson 3 on operations on functions. So we learned about composition of functions last time. Today we'll learn more about the domain of such functions. Our schedule today, first we're going to go over homework questions from last time, and then we're going to review the simple, actually no, I forgot to change this. First we're going to review the composition, and then we're going to learn about the domain of f of g. Okay, and then we're going to do practice problems. So for the homework, I think we had f of x is equal to x squared minus 4, and g of x is equal to square root of 2 minus x. Find f plus g, f minus g, f g, and f over g. All right, so I'll just give everybody a brief moment to just put your answers in the chat. All right, let's see what everybody got. Go back to the slides. All right, I'll give you like 1 minute to put your answers in. All right, we'll just continue. So, how about Kaylee? All right, Kaylee, could you volunteer? Kaylee, are you there?
Yeah.
All right. Okay, so I'm just gonna have you find all of these. F plus g of f plus g of x is gonna be equal to.
Is it x squared minus 4 plus the square root of 2 minus x?
All right, very good. So it's very easy, right? This isn't that hard. What about f minus g?
X squared minus 4 minus the square root of 2 minus x.
All right, and f times g?
X squared minus 4 in parentheses, and then the square root of 2 plus 2 minus x.
All right, and finally f over g?
X squared minus 4 over the square root of 2 minus x. Sorry.
All right. So, Haley, I'm gonna have you answer the next question as well. All right. So let me just copy all these answers down. So these next few questions are just very they're just related. Right. Give me a second to copy these down. This is going to be x squared minus 4 plus square root of x minus 2. This is squared minus 4 minus square root of x minus 2. This is x squared minus 4 square roots, and then this one, there's no parentheses. All right. So now I want you to find the domain of these, okay? Kaylee, how do you find the domain?
You find what it cannot be, and then you say what it can be. So the domain is like what x can be.
Kaylee, I'm having trouble hearing you. Can you speak up, or is it the mic not working?
Is it what x can be?
Yeah. The domain is what x can be and the restrictions, right? So let's see here. So f of x is equal to x squared minus 4. Are there any restrictions on that?
No, I don't think so.
Yeah, there's no restrictions. What about g of x?
It has to be 2 or greater.
Very good. It has to be 2 or greater. 2 to infinity, right? So because there are no restrictions on f, and the domain is just f intersection with g, then what is the domain of this?
Is it 2 and infinity?
Yeah, it's just 2 infinity. And similarly, what is this?
Is it the same?
Yeah, and similarly, what is this?
Okay.
All right. And finally, how do you find the domain of this? Kaylee, I'm having trouble hearing you. Is your mic working?
Um,
You can type it in the chat if you want.
okay.
All right, so Kaylee, you can type in the chat. What is the answer for the last one for the domain? It's this one. Should be very similar to the last few ones, right? So I'll just do it. Okay, so it's very similar to 2 to infinity, except that this time 2 cannot be included because g of x cannot be equal to 0. So therefore, it's just 2 to infinity. Uninclusive, right? Include, yeah. Okay, so next we can find f of g and g of f. Let me just copy down these functions again. All right, so let's find a new volunteer this time. All right, how about Ethan? All right, Ethan, could you tell us how we do number 3?
So you basically you put the g function inside of the of the f function.
Good. And so what is the result?
I got -2. I mean -x minus 2.
All right, so let's try. Should be square root of x minus 2 squared and then minus 4. So we should get x minus 2 minus 4, x minus 6. Did you get x minus 6 or?
I think I might have done it wrong.
All right, simple calculation errors, not too big of a deal, but you get the concept, right? So let's do the next one. What did you get for the next one?
I think I got a square root of -x squared plus 6.
Negative x squared plus 6. Let's see. So we sub it in for x, right? Minus 2. Are you sure you got negative x squared? It should be x squared just minus 6. All right. So that's it for the homework review. Let's review again our two function operations again. So f plus g of x, right? It's just going to be f of x plus g of x, correct? Like that's it. And f minus g of x is just going to be equal to f of x minus g of x, right? There's nothing too hard about that. And similarly, it's just f of x times g of x, and again, f of x over g of x. Now again, you can find the individual domains. That's probably the first step when you want to do to find the individual domains of each of the functions when you're finding the function of both of them. So because if you want f plus g of x to be real, then both f and g have to be real. So therefore, x has to be both in the domain of f and in the domain of g. So then we can see that the domain is just going to be the domain of f intersect with the domain of g, correct? And subtraction is very similar. Same almost, right? Because subtraction is just adding a negative number. So similarly, it's also domain of f intersect with domain of g. Again, with multiplication, there are no specific restrictions. So it's just domain of f intersect domain of g. Now you have to pay attention to f over g of x, right? It's the same at first, but also x, g of x, also g of x cannot be equal to 0, and that's a key point, all right? So if you don't know, if you did not write that down, write that down. It's a key point. So g of x cannot be equal to 0, otherwise it's dividing by 0, and that's undefined, right? So in addition to intersecting the domains, f intersect with g of x also has to not equal to 0. All right, are there any questions right now? Any questions? If there are no questions, I will continue. So now we go into the composition of functions, okay? So the composition of functions is actually very simple if you think about it, right? It's very simple. And it's basically, as Ethan said before, putting the g of x inside the f of x. So in this case, the whole g function is the input of the f function, and the composition is the output. And in g of f of x, the f function is the input of the g function. That's the composition of functions. One function is inside another, right? So as you can see here. So let me actually try something with a table. Okay. Let me think real quick. All right. So for example, if you had if there's a table, when you actually learn this in school, I think some problems have one of these, the the tables, right? So they have 1, 2, 3, and then g of 1, 2, and 3, maybe, you know. Actually, we can mix it up a little bit. All right. And then maybe they have you find like f of g of 2. Okay. So when g of 2 is going to be equal to 3, right? So then what is f of 3? F of 3 is 2. Actually, I did not mean to do that. Then f of 3 is going to be 2, right? Because look, g of 2 is going to be equal to 3, and then f of 3 is going to be equal to 2. And sometimes they have you do problems like that. It's very, very nice. Okay, so that's why you sometimes need to use composition of functions. All right, so let's do an example, just a very quick one. Let's say we have x plus 2, and then actually I'm going to do an example on fraction compositions, for example, like x plus 1 over x minus 1, that's f of x, and then g of x is going to be equal to 3x plus 2 over 4x plus 1. And then if you find f of g, it looks very complicated, right? But actually, you can do something that makes it not so complicated. So if you put the g function as x, for example, something like this, what you can actually do is you can multiply 1, but instead of just multiplying 1, you can multiply 4x plus 1 over 4x plus 1. And if you divide that, it's just 1. So it really doesn't change anything. This is called multiplying the denominators together, so you get rid of them. All right, so it's just going to be 3x plus 2 because these cancel. These cancel. 3x plus 2 plus 1 times 4x plus 1, which is 4x plus 1, over 3x plus 2 minus 4x plus 1. And you can see if you simplify, it's just 7x plus 3, and then negative x plus 1. So that's how you do like compositions of functions that have fractions in them. You can multiply them, that denominator. We're going to do example on that, I think. And for the g, it's quite simple as well. It's 3 times fx plus 1 over x minus 1 plus 2. And then 4 of x plus 1, x minus 1 plus 1. Again, multiplying the denominators here, x minus 1, and just multiply it like that. Or you can multiply 3, you can multiply 4 here and simplify it, but it's very, very tedious, so I do not suggest doing that. And if these just cancel out, so it turns into 3 times x plus 1 plus 2 over, actually no, plus 2 times x minus 1. Okay, and then you have 4x plus 1 plus 1 times x minus 1. And you can see if you simplify it, there's going to be 5x, and then plus 1 over 5x plus 3, I think. Is it? Yeah, I think so. All right. If I didn't make any mistakes, it's just small calculation mistakes, right? And you can just you can fix that in the homework anyways. Just this principle of multiplying the denominator is a key point, right? Very important. You need to know how to simplify them very quick. So, any questions so far? So I don't think there are any questions. There are no chat messages. So I'm just going to continue with the domain of compositions. All right, so it's very important to also know how to do the domain of compositions, right? So what you need to do is you need to make sure that the composition is real, but also the inside function is also real. So let me just do that, okay? F of g. So this is basically just equal to f of g of x, like so. And then you can see you're just substituting g of x inside as x, basically the input of f. And that means that first of all, the input of f, in this case g of x, has to be real. So the domain of f of g is equal to all x that are in all x in the real number set, such that x is in the domain of g, right? Of course g has to be real, right? Of course. And since g is the input of f, since g is the input of f, then g of x in turn has to be in the domain of f. And that is our domain restrictions, okay? So that's how you do it, right? So I might do an example with one of those. So does everybody understand what I'm talking about here? Actually, I'm going to do something. Okay, so how about let me just erase this again, and let's see if we can have someone who can restate that. Okay, how about Kaylee again? Let's see. Kaylee, all right. If you can do this, you're usually pretty good. So let's see if you can state the domain restrictions. All right, Kaylee, can you talk?
Maybe.
All right, I can hear it. That's good. Just make sure to speak up. So again, could you go over the domain restrictions of f of g again? So first of all, the input has to be real, right? The input of f. So what is the first domain restriction?
I'm sorry, I don't know.
All right, that's fine. So the first domain restriction, just follow along, okay, is that x has to be inside the domain of g, right? Do you agree?
Yeah.
All right, so x has to be inside the domain of g. Otherwise, the whole function would just be completely false because the input of f in this case is just completely just undefined, right? So that's the first thing. There's a second thing though. You see, f also has its own domain aside from g. That means g of x, the input of f in this case, also has to be inside the domain of f. Do you understand now?
Yeah.
All right, good. So let's do an example, okay? Let's do an example. So how about let's do this one. So f of g of x is equal to 7x plus 3 and negative x plus 1. So Kaylee, could you tell me for the only looking at this, what is the domain? What can x not be?
It can't be.
Well,
And-
the denominator can't be 0, right? So
Yeah.
what can x not be?
1.
Very good. It cannot be 1 because then -1 plus 1, that's equal to 0. That's undefined, right? So looking directly at this, it's just going to be x cannot be equal to 0. I mean, x cannot be equal to 1. That's the domain of this specific fraction. But if you look at this, that is not the only restriction. That's not the only restriction, right? It's not only x cannot be equal to 1, it's also something else. So first we have to look at that. Okay, so let's rewrite these functions. F of x was equal to x what was it, x plus 1 minus 1. G of x is equal to 3x plus 2 for x plus 1. All right. So first of all, Kaylee, what is the domain of G?
Is it that it cannot be negative? Negative 1/4.
Very good. It cannot be -1/4. X cannot be equal to -1/4. So the domain is going to be equal to x cannot be equal to -1/4. That is going to be G's domain. That is x cannot be equal to -1/4. That's the domain of G. Now, Kaylee, what is the domain of F?
X cannot be equal to 1.
Very good. But since what is acting as x in this case? It's g of x. G of x is the input of F. So therefore, g of x cannot be equal to 1. Do you agree?
Yeah.
So then all we need to do is we need to solve for that. If you solve it like a regular equality, right? It's very simple. For example, like this, you just solve it like an equality. Cannot be actually. So 3x plus 2 over 4x plus 1, which is G, cannot be equal to 1. So 3x plus 2 cannot be equal to 4x plus 1. You just cross multiply. And then similarly, 3x, oh, actually, no. Negative x cannot be equal to, and you move it to the side, right? Cannot be equal to -1. X cannot be equal to 1. Again, earlier, we had stated that x cannot be equal to 1, right? X cannot be equal to 1. But that was not the only condition. X can also not equal to -1/4. So now we see that the entire domain is going to be -infinity to infinity, but skipping -1/4. And we're skipping 1. Actually, I forgot the union signs. Let me rewrite this again. -infinity to -1/4. Union -1/4 to what? To 1. Union 1 to infinity. Okay. So that is it, right? Now I'm going to talk about an alternative method. This one is actually exactly the same as the last one, but it's just more simplified. This one is the domain of G is going to be equal to the domain of G intersection with the domain of f of g of x. And what I mean is, we're just gonna use the previous functions. All right, previous functions, and I think it goes like this, right? No, it's like that. All right. So we're just gonna use those previous functions. And what I mean by domain of f of g of x is the domain of this individual fraction, and it's just more simplified, right? The domain of g is x cannot be equal to -1/4, and the domain of this is going to be equal to x cannot be equal to 1. So we get the exact same result as what we had last slide, right? So we're just intersecting those. Actually, this alternative method is just a faster way of doing this, right? Without setting this inequality. Right, so I usually use the alternative method. If you want to like be more standard and you can do this, right? Using this is good because you understand why it works, right? Okay, so finally let's do some practice problems. All right, if f of x is equal to -9x minus 9 and g of x is equal to the square root of x minus 9, find f of g of f in their domains. All right. So we know how to find compositions already, and we learned how to find the domain thing. So I'm just going to give you a few moments to do this. All right, so I'm going to solve this. So if f of x is equal to -9x minus 9 and g of x is equal to square root of x minus 9, find f of g. So let's do that. We're just going to plug that in, you see, and that's that, right? And we should find respective domains first. This is infinity to infinity, which no restrictions at all. This is going to be greater than 9 inclusive. All right. So the domain of this, again, is going to be the domain of G intersection with the domain of this, which is just the domain of G. Next, we have G of f of x equal to square root of -9x minus 9 minus 9 again, which is going to be square root of -9x minus 9, 18. So let's find the domain of this first. -9x minus 18 has to be greater than 0. So x has to be less than or equal to 2, right? Think about it. Yes. -2, actually. Yeah, less than -2. So if -2 greater than -2 would mean, yeah, it has to be less than -2. Okay, and we also need it to be greater than 9 and, well, yeah, has to be greater than 9. Okay, so we're just going to, actually, if you think about it, it's less than 2 greater. There's no intersection, so is there no domain for it? It's weird. Okay, for now, we're just going to say that we're going to intersection these, right? And that means, actually, okay, I'm dumb. Didn't mean to do that. Okay, we're not finding the domain of G anywhere. We're finding the domain of F. Okay, so then it's just -infinity to -2, because now it's G of F, so it's different. This is an inclusion. All right, so let's do the next one. All right, let's do this one as well. X plus 2 and the square root of x plus 2. Okay, so we might run out of time, and we might not be able to do the last problem. But that's fine, because you guys know how to do these fractions. So the first one is just f plus g, right? So if we sub in g of x for x and f, then it'll look something like this, right? Let's see here. So it's going to be equal to x square root of x plus 2, right? And the individual domain for these is -2 to infinity. And this just has no restrictions, right? And you see here, the only restriction here is just going to be this. So, and then g of f is going to be equal to, it's going to be equal to x plus 4. You can see here, the domain will be -4 to infinity. I think that's all we have time for today. Actually, let's try this last one. Let's try this last one. Okay, I'll just solve it. Okay, and walk you guys through it. So you see here, we're just going to sub in g of x, like so, right? And remember the denominator trick. All right, you're going to multiply 2x over 2x, which is going to be 3x minus 1 minus 2 times 2x over 3x minus 1, and then plus 2x. You can see here it's just going to be equal to negative x minus 1 over 5x minus 1. Okay? And the domain, you see, you have to find the domain of this first, right? It's going to be 1/5. So x cannot be equal to 1/5. And the domain of g, which is x cannot be equal to 0. Like so. And then you can find the domain. G of f, very similarly, let me write smaller this time. It's going to be equal to x minus 2 over x plus 1, 3 of that, minus 1 over 2 of that. Multiply again denominators, x plus 1 over x plus 1. Then you just get 3 of x minus 2 minus x minus 1 over 2 times x minus 2 over x plus 1. Well, there's no x plus 1 anymore. There we go. It's just going to be equal to 3x, it's just 2x minus 6 minus 1 is -7, and 2x minus 4. Again, this is going to be equal to x cannot be equal to 2. That's the domain of this. And then find the domain of f, which is x cannot be equal to negative 1. All right, so those are the domains. Okay, so thank you for listening today, and I'll see you next week. All right.